Hello, how's it going? My name is Grant Fritchie. Welcome to the Community Circle presentation. Today we're going to be talking about the tools that are built into Microsoft SQL Server that help you do query tuning. We're not starting officially for another 4 minutes, but I like to get on here and just kind of get warmed up, give everybody a chance to come on in, do some housekeeping, answer any questions that are outstanding from last week, and just generally get ready to go. This week we're going to be talking about execution plans. That's right, this is the big one. This is the one everybody loves. I love execution plans. You love execution plans. We love execution plans. And we're going to get a chance to talk about them quite a lot. So I'm pretty excited about it. Just get my glasses ready so I can actually see. Make things much more easy for me so I can tell you what's going on. And we'll keep going here, and again, about 3 minutes will be the official start time. If anyone has any questions or anything, we'd be happy to answer them. There is a live chat window. You can use that to ask questions as we get into the topic. Feel free to interrupt at any point, ask for clarifications. And there is a Discord server for questions after today. So if you've got questions that are outstanding, you can go to the Discord server. It'd be a great way to get them. I generally will see any comments you post on the videos, but I haunt through the Discord server on a regular basis. Now the Discord server is in links down below. You guys can see it down there. And there's, yeah, that's about it. So about 2 more minutes, we'll get going with the official start time. I hope this proves useful to everyone. Pretty excited about it. I love talking about execution plans. It's just a big topic for me. I've got 3 editions of a book out on it. Well, technically 4 editions, but only 2 rewrites, so 3 editions. And the 3rd edition is probably 4 times the size of the original book, more than twice the size of the first rewrite. So it's worth picking up. It's free to download, so you can get a copy of that. Please do. So it's a free book just for you. Sadly, my book on execution plans is not free. Apress charges for the 1,000 pages, but that's how that goes. So we'll get going here in about 2 more minutes, 1.5 minutes. Okay, this is going to be fun. It's going to be a good day. We're going to learn a lot of stuff, share a lot. That's the plan. Lots and lots of sharing. By the way, these videos, well, I'll talk about that in the intro. Don't want to give away all the stuff before we get going. Okay. Looking good. Looking good. I've got multiple monitors that I'm checking out here to keep an eye on things. Watching the time down there. Then I've got to worry about the studio, and then I've got all my actual stuff up on the big screen so I can see it. And we'll get going here shortly. Okay, I'm going to call it close enough. Let's just switch to video and screen. There you go. This is all taking part as part of the community circle, Redgate Community Circle. Now, the Redgate Community Circle is very much just a way for us to give back to the community. That's all it is. There's no actual Redgate stuff involved. This is about you and me helping you out, hopefully, with the data we're talking about. Now, the videos we've been producing, there's BI from Steve Jones, reporting services from Kathy Kellenberger, and beginning T-SQL from Kendra Little. They've all been free. They will all be free. They're going to go online, stay online. These are free lessons for you. Use them. That's it. Done. Going on. In the comments, or sorry, in the description of the video, you can see links to the community circle. You can see links to the code that I'm using today. You can see links to the slides that I'm using today. So you can get copies of every single thing. There's nothing hidden, nothing kept from you. It's all available, all online right now, today. Go click on it, download it, get it. All of these videos will stay online forever for free. So they're going to be completely out, open and exposed for as long as you guys find them useful. They will be available for you. With that, ready to start talking about execution plans? I am. Let's go. So today's topic is SQL Server execution plans. They are the tool for performance tuning. They're the one tool that you really get that lets you know what SQL Server itself is doing. Now, before we get going, tell me just quickly about myself. My name is Grant Fritchie. I work for Redgate Software as a DevOps advocate. I am a Microsoft Data Platform MVP. I've been involved in IT for over 30 years, building software. The gray hair is real. I've been around the block a couple of times. My favorite topic in the world is execution plans. I'm not claiming I know everything about it. I do not. There's just constantly more things to learn, more to explore. But I've been working with them for a very long time, and I really want to share the knowledge. This is my contact information. If you have more questions after today, like I said, there's a Discord server and the links down below you can use. Or feel free to send me an email, stop by my blog, contact me on Twitter. I'm more than happy to talk and try to answer questions and help out. So I'm making everything available for you so you guys can get in touch if you need to. That's right out there in public on YouTube forever. There's my email address. So how much more can we do, really? So let's get going. What is an execution plan? Why do we care about these silly things? Why would you sit and watch this video? And the fact is, an execution plan, as it says, describes the set of operations that the execution engine of SQL Server has to do in order to satisfy whatever query you've written. Whatever that query says, whatever that query is trying to do, select, insert, update, delete, there has to be a way for SQL Server to satisfy that within the constructs of SQL Server itself. So thinking about it, what do I mean by that? Well, obviously, tables, columns, data types, yes, but also primary keys, foreign keys, any other kinds of constraints that you have in place. All of these are going to impact that. Data length is going to impact that. The indexes, the statistics, every bit of stuff inside of SQL Server affects the way execution plans get generated and affects what you are going to see when you look at that execution plan. But more importantly, all of this stuff affects very directly the performance of your queries. And so if we are trying to tune a query, if we are trying to make something run faster, execution plans are one of the principal tools that you would use to deal with that fact. Okay. Now, this is an execution plan. This is it. That's all there is to it. It's pretty simple, pretty straightforward. It is a set of what we call operators. They are also called iterators because they can iterate over rows, meaning one row at a time. They can process the rows. Generally, operators is the common phrase. They are connected by little arrows, also called pipes, and this is it. Each one of these things represents an operation. Each one of these things is telling you something about the way SQL Server decided to take care of the query that we have defined and to take care of the objects and constructs inside of SQL Server. So it's pretty, that's it. I mean, that's really it. The thing is that probably when you go to look at an execution plan, you're probably looking at something problematic. You're probably looking at something causing you pain, which means you're probably not looking at, 2, 4, 6, 8 operators. You're probably looking at 80 operators, 800 operators. You're looking at something crazy and big. And all I can tell you is that when you get to the really big ones, it's still the same process as it is with the little tiny ones. You're going to run through certain things and do things a certain way to understand what's happening, because it's all about understanding. It's not about having, some perfect knowledge of the way the Microsoft SQL Server internals work so you can immediately identify a problem and immediately come up with a solution. That's just not going to happen for anybody. no matter who they are, generally you're going to have to go in here to get some understanding. So you're going to see things that you recognize. You're going to see things you don't recognize. You're going to see things that you understand. You're going to see things you don't understand. But the way we approach them, whether we understand them or not, is always the same. There is a methodology. There is a pattern. And I'm going to try to walk you through a bunch of that today and next week. There's going to be 2 classes on execution plans. So this is an operator. Now, generally the operators consist of, clustered index scan, the actual object. So the clustered index scan is the operator name. Clustered is describing the type of index scan that you're getting from a clustered index scan. And then the object name is sales order detail.pk.sales order detail. And then it has an estimated cost. All plans have estimated costs, not real costs. We're going to talk about that in some great detail. Each of these operators has an input and an output, with one exception. There's one type of operator we'll get to in a little bit that's not technically an operator. And we'll talk about that in some detail. We then have 3 other little bits of data. We have a thing called Tooltips, which is the little bit of yellow there. Honestly, the more often than not, they just get in my way. They're not that useful. They can be, depending, but there they are. There's the little pipes. Remember the little arrows connecting up the operators? The arrows are representations of, not measures of, representations of data flow. Cool, easy enough to understand. And then there on the right is the property sheet. Now when we look at property sheets, this is the property sheet, which is the same as the tooltip, and both of them are for that little arrow there. Every one of the objects inside of an execution plan has got a property sheet when we look at the graphical execution plan. And interestingly enough, there's a lot of data in the property sheet, but not necessarily visible in the tooltip. This is the one exception where every single item that's on the tooltip is also in the property sheet. It's just in a different order. Don't ask me why, I don't know. It has something to do with Microsoft coding. That's all I can tell you. All right. Now this is what the kind of property sheets that you're looking at and you're going to see more frequently. This is the property sheet for a clustered index seek, and it's showing all of the variety of possible data that's going to describe the way that single operation is satisfying the query. In this case, a clustered index seek, meaning it's using a clustered index to walk the B tree to retrieve a very, very particular range of rows, 1 or more, or 0 or more if it can't find any. But anyway, you get the idea. But you can see with most, not even all, most of the details expanded out, this is a gigantic set of data. Now I know that you can't see everything here. We will be zooming in and out on these things as we talk about the details that you have to get used to looking for. So we'll walk through a lot of that stuff. We're going to spend a lot of time walking through execution plans today and next week. So don't worry, you're not going to get gypped in terms of execution plans. So let's talk about this. This is important. The Microsoft terminology today says that we have 2 kinds of execution plans. There is an estimated execution plan and there is an actual execution plan. And this is what you see in the Microsoft documentation. Right? It's really important that we're clear. That's what the documentation says. What we have is something different. What there really is not that. It is actually a different thing entirely. And so let's talk a little bit about that, because it's important to understand. There's only one kind of execution plan, for real. Hello? Yes, there are people here. I'm talking. Is this not on? I've been sitting here talking, there's viewers, and it's not working. That would be freaky, but I can see the mic. It's definitely going. All right, I think we're okay. I'm going to keep going. There is not two kinds of execution plans. I know that Microsoft says that, the documentation says that. Heck, the previous two versions of my book very much imply that there are two kinds of execution plans, estimated and actual. But in fact, that is not true. There is one kind of execution plan, period. And then there is the ability to capture runtime metrics and add them to the execution plan. And that's what we call an actual execution plan. Okay, so it's not two different things. We have to get on top of that as soon as possible, because trying to assume that, well, yeah, but Grant, if the query recompiles during execution and there's a change in statistics causing a change in the row counts, I can get a different plan for the actual plan than for the estimated plan that I ran last week. Yeah, you're right. That doesn't change what you are looking at. And the reason it's so important is because when you think, well, this plan is different, you lose track of the idea that the plan you're looking at is still just an estimated plan with estimated row counts and estimated costs associated with each of the operators. All estimates, all calculations. Some of those calculations are displayed inside the data of the plan. Some of those calculations are only visible inside the GUI. So you won't always find every piece of data in the GUI inside the XML. In some cases, there's actually stuff generated. So the thing is that you need to know that those are estimates. They are always estimates. And we can add runtime metrics. And so the way we like to think about execution plans now, and a number of us are working on Microsoft to change the documentation. Let's call it an execution plan. What do you have in Query Store? An execution plan. What do you have when you get at what we call an estimated plan? The execution plan. What do you have in the DMVs? An execution plan. Those are all execution plans. What if you add runtime metrics? Okay, that's an execution plan plus runtime metrics. We also call them exec plan plus or plan plus, and it's just an execution plan plus runtime metrics. Easy enough to understand, and it makes explaining execution plans so much easier, especially because it's more clear. And clarity is so important. When we're talking code, we're talking DevOps, we're talking query tuning, no matter what, clarity drives what we're doing. When we're unclear, we cause problems. Either we cause the problems or the unclarity that we have can lead us to cause problems. If we know what we're talking about, if we know the data in front of us, we can make better decisions. And that's what this is all about. Clarity in order to make better decisions. Plus, it's just easier to teach it this way. There's an execution plan, and we can look at them. And an execution plan is useful. Always. And if you add runtime metrics, it's more useful. Cool. Therefore, it's different than when we say, well, there's an estimated plan. Estimated, God knows what it's like. And there's an actual plan. Well, I don't want the goofy estimated thing. I want the actual plan. Yeah, but the problem is the actual plan is an estimated plan, but it's also got some runtime metrics. Now, I'm not saying that we won't go after those any chance we get. We will. They're really important. It makes a big difference, and we'll talk about why. But let's establish up front what we're talking about in terms of language. There is an execution plan, and there's an execution plan plus runtime metrics. Enough. We'll keep going. So, what do we see when we see plan metrics? What are we talking about? These runtime metric things. Well, we get to see really important stuff. So, I mean, it's why I emphasize so much that I'm not simply ignoring the execution plan plus. In fact, I want what's there. Because when we look at the plan itself, just the query plan, it contains information about the execution if you've got an execution plan plus. And that information can include stuff like the memory grant info. How much memory was granted for this query to execute? How much was estimated? How much was actually consumed? Huge, huge query performance tuning piece of information. What are the parameter runtime values? Also, for that matter, what are the parameter compile time values? What did it compile for and what did it run as? Are there differences in the row counts between those two? Gosh, maybe that's why we're seeing bad parameter sniffing. You're going to get the weight statistics in the Execution Plan Plus. It's going to be there. You're going to see weight statistics stored with the plan if you capture it. Not if you pull it out of the DMVs, not if you run out of query store, and certainly not if you don't execute it. But if you capture it, if you're able to execute the query, you will see that stuff. We also get query time statistics. Yes, it stores execution times now. By the way, those execution times are very much in keeping with the SSMS properties window, which I showed last week. Hopefully you guys saw it, and if not, go back and watch that video. And extended events, which I showed week 2, yeah, I think, and I'm losing track now. And very much in keeping with all the other details. If you see a query time, that's accurate. You're also going to see the degree of parallelism, and you're going to see memory grant. Oh, I already said memory grant info. You're going to see the degree of parallelism for the execution of the query. All of this stuff are about the plan itself. This is all stored in the plan header, which we're going to look at. Don't you worry. Now, the other things that you're going to see are the operator metrics. Now, the operator metrics are where things get fun because the actual, see, I even still say it. It's hard to get out of the habit. The Plan Plus runtime metrics has all of this data, the actual reads, the actual writes, the number of batches, the actual number of rows, read behinds, input memory grant, output memory grant, per operator. And it doesn't end there. I mean, there's a reason why we love the Execution Plan Plus runtime metrics. It includes the lob read-aheads, the logical reads, the actual number of executions, the actual end of scans. Yeah, useful data. We're going to go after it, but know that it's not about just getting estimated or actual. So now, if we're presented with a plan, here's a marginally complicated plan. It's not terribly complicated. It's a little complicated. The question is going to be, where do you go to get started with it? How do you start reading this execution plan? Because the information out on the internet has been problematic. And that's partly my fault. I wrote a book in 2005 on SQL Server execution plans, and I had a particular bit of knowledge and way I thought that they worked. And so I communicated that to everyone, and it wasn't entirely accurate. There were problems with it. And so other people have come up and said, okay, well, no, this is the way they work. And that's not always entirely accurate. And so we've now come to a place where there's really good knowledge out there of exactly how these things work, exactly what they do, and we've been able to put it together in a way that we're communicating it with everyone so you guys can actually see it and see what's going on. So when we get one of these, where do you start? A lot of people will say, well, you start on the right. Well, the right where? Well, the top right. Well, okay, why? Well, we don't know. That's just what we do. We start on the top right. Other people will say, well, no, you can never start there. You always start on the top left. Well, okay, why? I don't know. That's just where you start. Thing is there's reasons for both. Starting on the left or starting someplace else. There are reasons for it. However, I'm going to tell you one thing and one thing only. Always, always, always start with the header. What's the header? It's that first operator. It's the only one highlighted. It's a little blue dot on your screen, really, but it's the only one highlighted all the way over on the left. That's the first operator. That's the operator that has the header data. And that header data tells us stuff about the plan itself, about the choices made by the optimizer and why it made those choices. So that gives us data to start making our decisions. Now, as you start to work through execution plans, and what's going to happen is you're not going to look at one plan 5 minutes, never look at it again. I mean, that might happen, but most of the time you're going to be in a plan for a day, 2 days, a week. These things get ugly, they get hard. You're going to spend time trying to understand what's going on. I get it. Are you going to look at that header every single time you open the plan? Nope, you're not. Because as you're working with the plan, you know what the header information has for you, and you're probably aware of changes you are going to make that may affect that header information. But as you're working with the plan, you get more and more focused on, oh, hang on, I don't care about the header right now. I care about that table spool. Why is it there? What's going on? What do we need to know to understand where that came from and why it's being used? Let's dope that out. Not worry about that header information because we've already looked at the header. That's an acceptable approach. But we start with the header and then we read the execution plan. We'll get to exactly how to read it in just a second. Hang on. The slide's supposed to advance and it didn't. So why am I telling you the first operator? The reason being is all that information is contained about the execution plan. It's rather detailed. And so I want to start with that first operator and get those details, understand the choices made by the optimizer. Once I've got those choices made by the optimizer, once I've got that understanding, cool, I can go on. When I go on, what are the next things I look for? Well, let's just keep using this execution plan. The next thing I look for is warnings. Now, warnings are easy to spot. If one of these operators had a warning, it would either have a little red X or a little yellow traffic alert thing that looks like an exclamation point. Either one of those things is a warning. Warnings are not bad. Oh my God, there's a warning. No. It's just informational, right? Hey, look, there's something weird in this execution plan. Let's go see what it is. And it could be very benign. There's all kinds of warnings that are false negatives, false positives. I believe one of my examples has one. So when we get to it, I will point it out and make sure that you guys know what it is. But it's okay. But they are a poke in the eye. I always call them that. It's that thing that draws your eye. Well, what's that? Look, a red X, quick. Let's go see what the red X means, because it's almost like set up for management. Red is bad, Red's not bad. Red's great. But anyway, you get the idea. So that's next. First operator, get the details. We'll go over what they are. Second, warnings. Get those warnings. Understand what's going on. Third, look for the most costly operators. Now, those operators, every single one of these costs that you see here is an estimated cost. They are not real costs. That's on an execution plan or an execution plan plus runtime metrics. But if we look around on the screen here, what we're going to see is that one of these operators has a higher cost than the others, and we probably should look at that to understand why. What is it doing that's making it cost so much, and is there anything that we could do to the query, to the indexes, to the statistics, to the constraints, any of that stuff? Is there any changes we could make to change that behavior and enhance the performance of this query? Maybe there is, maybe there isn't. It really depends on the operator and what it's doing and why it's there. So it's not simply identify that, oh, look, there's that, throw an index on it, we're good. No. Why is it there? Is it bad? Is it good? Is there something we need to worry about? You're going to see in the first example that it's actually harder than it sounds. Next, we're going to look for fat pipes. And that's the pipes, remember, are the little arrows that move between the operators. Now in this example, there is actually only one pipe that you could even pretend to call fat, and it's over way on the right-hand side where it says clustered index scan, and then it does a filter operation. Now that's an interesting two sets of data that would be worth exploring for execution plans, because that's what we call late filtering, meaning it read all the data and then filtered. Okay, that's costly because you like it to filter as it reads the data. Cool. Obviously, gives us an opportunity to start saying, well, okay, maybe there's something we could do to change the query, change the statistics, change the index, and make an improvement to the execution of that query. Cool. Next are what I call extra operators. Now, there's no such thing as an extra operator. None. But if you're looking at an execution plan and you go like, huh, concatenation operator, never heard of it. That's an extra operator. Or if you're looking at an execution plan and you see like, oh, table spool, cool, I know what that is. Why is there a table spool here? That's an extra operator. If you don't know what it is or you don't know why it's there, it's something that should draw your eye to make you understand what it is and why it's there. That's a good driver, a good indicator for fixing execution plans. Just a standard thing to look for. Next up, scans. Now, scans are not necessarily great, and seeks are not necessarily great. Scans are not necessarily bad, for real, and seeks are not necessarily bad. Either, depending on the situation, is going to give you some good data. And so we need to be able to look for scans and understand why we're seeing a scan, or even look for seeks and understand how much data the seek is doing. Because, well, we'll get to that in a second. Lastly, we're going to look at estimated versus actual, because those actual row counts versus estimated row counts matter. It makes a difference. So we're going to want to look for that stuff. So it's just the standard stuff. So these are what we look for. These are the order in which I look for them. The first time I'm in an execution plan, when I'm looking at an unknown plan, first time I've ever done it, I follow this approach. First operator, get details about the plan itself. Look for warnings, look for the most costly operations, look for fat pipes. And in terms of the fat pipes, look for transitions, fat to thin to fat, stuff like that, because that indicates data changes, right? Because the pipes are data movement. You know, big fat pipes getting thinner and thinner indicates some late filtering. Thin pipes getting fatter and fatter indicates we're adding data in some kind of exponential fashion, so what the heck's going on? We're going to look for those extra operators, we're going to look for scans, and then we're going to compare estimates and actuals. This is the guideposts. Is this all the detail? Is this everything that you do? Nope. But these are the guideposts. These are what we're going to follow to get going on reading an execution plan. And then it just gets ugly. But let me just tell you why the first operator, we're going to go look at it, because it has a whole bunch of data. And this is the property sheet for the first operator. It's got the ANSI settings, and ANSI settings affect execution plan behavior. It's got the reason for early termination, in this case, good enough plan found. It's got the query hash, the parameter runtime and compile time values. In this case, they match, so you know that this was compiled and run using the same values. You get optimization level. Did it do full optimization, trivial optimization, all that fun stuff. Missing indexes. If there's more than one missing index, yeah, did you know? That little green thing you see at the top of the screen, that's just the first missing index. There might be more than one. If there's more than one, it will be here. Compile time, how long did it take to compile? The plan size, how big is it? All of this is data about the plan that can start to drive your decision-making process, because you see a lot of stuff here that's useful and is going to tell you things. And that's why we go there. Now, after that, and this is the last slide, I believe, we're going to be going off and reading execution plans from this point forward. Yeah, I think so. What do you do? Well, first off, it's all in the properties. You're going to have to learn. Every operator has got some unique properties. Every operator has some common properties. You want to learn how to differentiate between the two, and also which of the common properties are important and which of the unique operators can you kind of ignore most of the time. And that's just habit and time spent working with it. Also, logic. You'll pretty logically quickly see which ones are, oh yeah, kind of look at that on a regular basis. Look at that, look at that. Next, identify nodes. Learn how to read through the node IDs and why the node IDs are in the order that they're in. We're going to make darn sure that you understand that today. Combine the plans and plan metrics. Never look at a plan and think of it as a measure of performance. Two reasons for that. One, plans are not a measure of performance. And two, capturing a plan, especially if you're capturing a plan to get those runtime metrics, has an associated overhead that negatively impacts query performance. In other words, if you think you're measuring an accurate representation of query performance, you're not. You're actually measuring a crippled level of query performance. You're hurting the performance and then measuring it. Don't do that. If you want to measure, measure. If you want to look at plans, look at plans. Don't do both. You separate the two and then use them in combination. Make changes, look at the plan, separate from measuring it. Yeah, it looks like it's better. Now let me measure it. Yes, it has improved. Cool. Let's look at the plan and see if there's any other opportunities. Excellent. And start working through it that way. But it's the combination of the two. Just remember that every operator is unique in what it does. A clustered index seek is not the same as a clustered index scan. Why does Microsoft not expose some of the real costs? They do expose some of the costs. Just sadly, they don't expose all of them. And I think part of why they don't expose all of them is because there's an overhead associated with capturing data. And so the more granular and detailed stuff you expect them to capture, the more overhead associated with that capture. So I think they capture the stuff that they can capture easily and the stuff that they can capture with low costs, because you don't want them, you really don't want it to cripple your performance in order for you to see things. You want to make sure that you're just seeing things. Hopefully that answered the question. All right, with that, we are done chatting today. We're going to go play with code for the rest of the day. I'm not even going to come back to the slide deck. So today is all about the code. Next week will also be all about the code. We will be doing nothing but looking at code and execution plans all week next week. I'll do a little lead in, but otherwise it's going to be just lots and lots of execution plans. Okay, cool. We've got a query. It's not a complex query. It's not doing anything nuts. You've actually already seen the execution plan from this query. I am hard coding some values. It is just a simple ad hoc T-SQL statement. Now, the way we can get execution plans is pretty straightforward. Up here on the toolbar, there is a toggle that we can turn on or off to capture the execution plan plus runtime metrics, also called the actual execution plan. Or we can, let's just scoot over a little bit. We can use this little button to just get an execution plan. Now, there's also a keystroke you saw. Come on, tooltip, come back up. There we go. You saw that there is a keystroke, so you can do Control L. I've never gotten in the habit of that. Don't know why, but we'll do it today. So if we do, not connected. And it's going to fail because it's going to be on the wrong database. Okay, let's fix that. That's what I get for doing things different. All right, we'll try it again. Control L. So it went out, and what happens is that when you say, give me an estimated plan, it's going to go and get an execution plan. Now, it's going to do one of two things. Number one, it's going to go and look in the cache. If the plan that matches the query hash is available, it will pull that plan out of cache. It will not run through the compiler. Just an interesting note, because you might see that if it recompiles, you could see a different execution plan, even though you're looking at estimated and what's called estimated execution plans. Oh, all these recompile things are so much fun. Anyway, once we've got it, we've got a plan back, we can see the plan. Now, so you probably recognize it a little bit. Let's get this out of the way, because we don't need it for the rest of the day either. So we can see that there's a plan. Now, we could start reading it on the left. We could start reading it on the right. If we start reading on the right, where do we go? We go up here to the first operator, all the way on the right, all the way on the top. Why? Why are those? There's that two discussions about left to right, right to left. All right, let's explain it. First up, most important thing to think about, the people who develop this probably are English-speaking, Western-oriented. In English, how do we read? We read left to right. If you were going to set up an execution plan, like we have here, and you wanted to read it, would you read it left to right or right to left? You would read it left to right. So why would they say, oh, well, so many people, myself included, several years ago now, I've long fixed it, but why would people say read right to left? Well, it depends on what's going on. So here's the way an execution plan works. You instantiate your execution plan, whatever the query is. In this case, a select statement. It could be an insert, update, delete, doesn't matter. Oh, and by the way, anything that is data definition language never, ever gets execution plans. Anything that's create an object, alter a table, no execution plans. They don't have execution plans. Only data manipulation or language queries have execution plans, just so you know. It's just how it works. So, you instantiate your query. It's going to do whatever it does. The first thing the query does, in this case it's select, goes, okay, well, I need data. I am a select statement. Please return data to me. If it was an insert, update, or delete, it would say, hey, can you return to me the status of whether or not you were successful? Now you're saying, well, wait, nothing's successful, right? Nothing's run. Exactly. It starts to instantiate. The query first says, okay, well, look, I've got to compile. I've compiled. I've put together a plan. When I execute, what I'm going to do is I'm going to run this nested loops join. The nested loops join is going to say, do I have any data to return? And the answer is no, I do not have any data. So it is then going to instantiate the other nested loops join and that clustered index seek. Each one will instantiate moving to the right until it starts to get data. And then it will start instantiating going back the other way. So in this case, we got this. And by the way, you can tell the node ID is 0. And then we got this, and you can tell the node ID is 1. And then we got this, and you can tell the node ID is 2. So 0, 1, 2. And yes, I use the tooltips. This is one of the few times I use the tooltips. But 0, 1, 2. And you'll notice that this one is node ID 14. It is not part of the instantiation until at the very end. So from a logical standpoint, query execution starts on the left and proceeds to instantiate to the right. So the hash match join down here, the node ID on that is going to be 3. 0, 0, 1, 2, 3. Cool. And proceeding on that way. But why did people think right to left? It's easy. The instantiation is left to right. So from a logical coding standpoint, we're going to read it left to right because that's how it gets instantiated. Where does the data come from? The data comes from the right. The data comes from that index seek. So if we're tracking the data movement, generally, we would start on the right-hand side of the screen and follow the data. If we're tracking the instantiation, the logical coding processes, we start on the left-hand side of the screen and follow the instantiation process. And we're driven by the node IDs. They help us to make those determinations. So that's a huge, huge fundamental concept. Get that one, have that one, and off you go. Okay? So, we've got this execution plan. Where do we start? Do we start reading it left to right? Do we start reading it right to left? Well, remember in my overview, I talked about let's start with the properties of the first operator. So we right-click on it, we select properties. The property window opens over on the right. I'm going to go ahead and pin it into place so we keep it. Oh, you silly bugger. It was already pinned. There we go. I'm going to pin it into place so we have it. And so you'll notice if we look at the tooltip, I'll zoom in on it so you can see it. The tooltip has got 5 properties. The plan size, the estimated operator cost, the estimated subtree cost, and by the way, and then the estimated number of rows per execution, 1. And then it's got the statement, the actual query. Now, the thing is that this first operator is not really an operator. It is not an iterator. It never has a cost. It never does anything. This is simply header information about the plan itself. This is pulled from a particular spot within the XML. It is not an operator. It's not one of the operators. Heck, if we take a look at the XML, I can prove this one to you. It's really easy. If we take a look at the execution plan XML, we can see that each operator is called rel-op, right? I'm not sure why, relational operator, I don't know. But if we go back up here, there's a whole bunch of information, and it's about the query plan, right? Stuff about the statement, the ANSI settings. Remember I said the ANSI settings were in there. The compile time, estimated pages cached. In other words, the header information about the query is all right here inside the, I said query, execution plan. Oh, effectively for the query too. But it's all right there. But we don't have to go through the XML and dig. We've got the properties window. We can look in it right here. However, let me tell you a bug. Microsoft didn't even know about this one. Trace, or profiler, and extended events can capture execution plans. Something about the way trace and execution plans capture, or I'm sorry, extended events capture execution plans, it doesn't have the same header format. And so when you look at the plans from trace or extended events, you will not see that first operator. Now, the good news is, so that's the bad news. The bad news is there's no header, therefore no nice property sheet to go look at, which we're going to detail on here in a second. But the header information is still there. It's just in the XML. You'll have to go and dig it out. I don't know why they haven't fixed it, but the last time I checked, which was about 6-8 weeks ago, it still didn't work. So I don't think they fixed it anytime soon. We will keep an eye on that, and I'll let you know if that changes. Now, let's talk about why we're looking at that first operator. Well, first up, plan cache size. Interesting bit of information. The cardinality estimation model version. In other words, what level of cardinality estimation engine am I using? Am I using the one post-2014 or am I using the one pre-2014? In this case, 150, we know it's a later one. How much memory, CPU, and how long did it take to compile this plan? Useful data about the plan itself. The estimated subtree cost is the overall cost for the whole plan. Why couldn't this plan not go parallel? Non-parallel plan reason. Well, it just couldn't generate a valid parallel plan, probably because the cost was 1. There's no way for this thing to go parallel because the cost is so low. We get the memory grant info, and there's a lot of detail in there. And I don't generally look at this unless I'm looking at plans that are, in fact, under memory pressure. But if you're looking at plans that are under memory pressure or queries that are under memory pressure, getting the memory grant info is a huge win. Let's minimize that. We've also got the optimizer hardware dependencies, degree of parallelism, so I could go to 2. It didn't. Estimated memory grant, estimated cache, all those fun things. These are all the estimates that are being used to come up with the plan. And then this one is extremely exciting. This one's only in 2016 and up. But we also get the statistics used by the optimizer to compile this plan. So you can see exactly which stats were used. Further, you can see the sampling rate on the statistics, in this case 100. You can also see the last time those statistics were updated, 4/28/2020. So they're, this I'm recording this in May. They're only a month old. No, wait. Yeah, May. They're only a month old. Not even a couple of weeks, really. And so we've got information about the statistics available with the plan now. Huge, huge difference in the information that we have available to us. It's not always going to be a massive decision maker for everything that you do, but it is going to be regularly used. We get the query hash, which is important. We get the query plan hash, which is important, very useful stuff. We get the reason for early termination. Now, up here, we can see the optimization level. In this case, it did full optimization, meaning nothing stopped it from optimizing. It didn't hit an error. Cool. And it didn't just do a trivial plan. The plan was not so just simple that it couldn't possibly do anything else but what it did. Nope, it did full optimization. But the reason for early termination, meaning it didn't finish optimizing. It did a full optimization process, but it did not complete that optimization. Why? The SQL Server Optimizer is a good enough plan mechanism. And so as soon as it finds a good enough plan, which is a mathematical construct that I'm not going to get into today, as soon as it finds a good enough plan, it stops optimizing and keeps going. But it is also a cost-based optimizer, meaning I will spend as much time as I think I need to based on the estimated costs, which are based on the query itself, the objects, and all that stuff. I will spend so much time, and then I will take the cheapest plan I have and, quote, time out, unquote. In short, this might be a plan that could be further optimized. Yeah, this is a really interesting one because people are always saying, well, gosh, if it times out, what can I do to fix it? Well, there's nothing broken as such. This is an indicator. It's not telling you that, well, the optimizer's broken, best burn it to the ground and move to Oracle. No, no, no. It just means that based on the costs associated with this query, it gave up. Usually, it's because the query itself is insanely complex. So simplifying it might help. Or you don't have the kinds of objects the optimizer needs in order to make good decisions. What it means generally is there's missing or bad statistics, missing or bad indexes, incorrect objects within the structure, or just strictly bad code that the optimizer is going to do its darndest to give you a good query plan, but sometimes it just runs out and doesn't have enough left, and therefore it times out. But you get to see it right here inside this first operator. Retrieve from cache, false. As we said, it's not going to compile it unless it has to. In this case, it had to. And then the optimizer set options, and then the statement. Great data, all in that first operator. And it's all stuff that will help you then look for and do query tuning. And so the next thing to do, again, this is when we're looking at a plan for the first time. Next thing to do is look for those errors, look for those problems. And I don't see any. Oh, by the way, did you know you could do that? Click and drag. As long as you don't release it, you just move the plan around. I've had people want to do this live. They're just like, okay, great. That paid for the day. Oh yeah, this used to be paid content, guys. You're getting it all for free. So you click and drag, and you can look around, and no, I don't see any bad problems there. Do we see any really fat pipes? Well, the indications are this one, estimated number of rows there is 19,000. So, that's probably more than the estimated number of rows here, because this one's pretty thin. Oops. Tooltips are so unreliable. There it goes. Estimated number of rows is 1, or maybe 265. We'll talk about some of the details around this in a bit when we talk about the details of reading a plan. But no, there's nothing that. So then we say, okay, well, scans. Well, okay, seek, scan. Scan. So there's a scan, and it's scanning 19,000 rows. That's a lot. There's another scan. It's scanning also 19,000 rows. Interesting. Key lookup, not a scan. Seek. Okay, cool. Well, we do have some scans. Maybe that's a problem. Well, before we say like scans are problems, let's look at the detail of a seek. You can read this. Index seek. What's an index seek? Scans a particular range of rows from a non-clustered index. Wait, what? A scan? An index seek is a scan? Yeah, a scan is a scan, but it doesn't necessarily have a start point. It probably starts at the beginning and goes through. A seek merely has a start point, and then it's going to scan, same as a scan, until it hits the end point. Now, what could the start point be? The beginning of the index. What could the end point be? The end of an index. This is why seeks are not magical. They're not necessarily good. It does depend on what they're doing. Not simply that, oh, well, seek, stop worrying. No. What's it doing? Well, in this case, the details are this one is being executed one time. It's returning one row. And yeah, we're done. That's it. So probably this seek is safe. Although remember, those are estimated values. Estimated number of executions, 1. Estimated number of rows, 1. So, cool. But if it has more, then the costs go up. All right, fine. What's the next thing we look for? The next thing we look for is operator cost. Now, 0, 0, 0, 1, 0, 11, 11, 11, 5, 0, 60, 0, 0. Oh, wait, 60. There we go. Key lookup. All right. Well, okay. I know what a key lookup is, but everyone out there might not know what a key lookup operator is. So what do? We get the information. The information says it's using a supplied clustering key to look up on a table that has a clustered index. Well, what's that mean? Well, it means that the data was retrieved. Let's go and look at the object here. The object is, oh, come on, screen, help me out here. The object is the index PK address ID on the person.address table, okay? So it's the address table. Well, where else could it be getting information? Well, on the address table, there's also an index for state province, and on the address table, is this on the address table? Oh no, it's the state province table. Okay, cool. So it's using this index on the state province table, and we know that it's using that non-clustered index. Now what's it mean? Well, the non-clustered index has a key and maybe some include columns, maybe. But if there are not enough include columns, then where does it need to go to get the data? Well, it has to go back to the clustered index. And that's what this clustered key lookup is. It's going to look up that data. Now, if there was not a clustered index here, if there was just a non-clustered index and a heap, it would be a row ID lookup or a RID lookup. I hate saying RID, but somebody recently said, don't you say RID? I'm like, no, I say row ID, but RID. It's going to do a row ID lookup. I almost said RID again. It's going to do a row ID lookup, and it's going to retrieve the data. Okay, cool. Well, why is it costing so much? Why is it costing 60% of the cost? Well, I mean, that's a lot. You know, you would think a 19,000 row scan would be a lot more than looking up one row of data. Well, again, the details. Let's look in here at the properties. So, the estimated number of executions is 265. What? Well, that's because this thing is estimated to return 265 rows. So what's going on is that it's going to go to an index. It's probably a 19,000 row table or more. It's going to go to that index, and it can get 265 rows. Cool, that reduces my overhead radically. So it's using that index seek to retrieve data. Cool, we understand what that is. We understand how that works. It's looking through the B tree, it's using that stuff, it's pulling that data back. It's joining up with another seek over here, and it's returning a few rows. How many rows? Estimated 265. Cool. Well, for each of those rows, it now needs to look up data. So, in theory, and this is based on, this is an execution plan, but it's what's called an estimated plan. This doesn't have runtime metrics. In theory, this key lookup is going to get executed 265 times. Oh, okay, well, 265 executions, even if they are fairly simple seek lookup type things, because this is just a key lookup, which is equivalent to a seek, just going to a different place to pull data out, that's pain-free. That's, but it's 265 times. So, yeah, okay, 265 times, even a little bit of pain-free stuff, suddenly you understand why that costs so much. So that's why instead of the clustered index scan over here of, 19,000 rows, it costs less or more. Okay, cool. Well, wait, if this one's 19,000 rows and this one's 19,000 rows, and they're both scans, 19,820 and 19,1100, 100. But why is this one double this one? Well, that's a clustered index scan, and that's an index scan. Okay, Grant, help me. Why is that double? An index, generally, not always, but the optimizer knows, and we can tell by looking at the properties, an index is smaller in size, generally, than a clustered index. Can they be the same size? Sure. Could they even be bigger? Sure. But in this case, we know that this thing is, the estimated row size is 19. You can see it right here. And that's based on the information inside the index itself. And the estimated row size here is 15. So more rows, bigger rows, higher cost, even though they are both scans. Ta-da! You're now reading execution plans. This is how we do it. This is how we go through the process. And it's all about walking through and seeing how things are instantiated and initialized, identifying the IDs, and then walking through the details of them. Now, we're not done. We're not even close to done. This is the first plan we've looked at, and we spent almost half an hour with it. Let's look at a second plan. What we're going to do now is turn on the actual execution plan, and we're going to execute the query. Now, by executing the query, I get an execution plan plus runtime metrics. And this is where things get fun. So Microsoft has introduced what I like. I like it. It's a nice new addition, but it adds some confusion. They've added the row counts on display as part of the query itself. Now, these costs here, that 11%, the 11% up here, you should recognize those. Cost 5, and over here, cost 60. Doesn't that sound familiar? Yeah, because it's just an execution plan. But we've added runtime metrics. And so now we see things like, well, we estimated 19,820 rows. We actually got 19,820, so it's 100%. We estimated 142, but we only got 3, so it's 2%. We estimated 265, but we only got 16, so it's 6%. And you get the idea. There's actually differences in those values. Now, if we were looking at this for the first time, we're going to start in the same place as we always do. We're going to start with the select operator properties. And you'll notice they've changed a little bit. There's more stuff now, because not only do we get the compile information, which is going to be exactly the same, but now we've got the actual memory grant. We're going to see differences in the memory grant info because we're going to see the actuals. We're going to see how much memory did it actually give us to execute this query. Cool. We're going to see the query time stats. Now, these are only if it runs for over a millisecond. In this case, it did 63 milliseconds with 57 milliseconds of CPU time. If it runs in microseconds, you won't see it. And finally, we get the wait stats. And this is also the same. It's only going to be in milliseconds, only waits that are in milliseconds. But we do get to see that, in fact, there was some wait on the SOS scheduler yield. So there was a little bit of wait on the CPU, nothing big, not a massive thing to worry about. But more data, more information that helps us in query tuning. We get to spot more behaviors. Okay, that's all cool and great, right? But are there query tuning opportunities here? Now, a lot of people are going to focus on one area. They're either going to pick the scans and go, we've got to fix the scans. The scans are bad, the scans are bad. Or they're going to focus on the highest operator cost, the key lookup, 60% of the cost, right? That's bad. We've got to fix it now. Okay. Well, so the way you fix that, well, you modify this index, right? So you go in here to this index, and you say, okay, well, hang on, what's it returning? What's it having to go and look up? Well, okay, so we're going to go down here to the output list and find the things that it's looking up. And what it's looking up is exactly one column, the city column. All right, so if we had the city column included on this the state index, right? The IX address state, state province, I think is what it is. If we included the city, we would eliminate that key lookup, and therefore the query is going to behave a lot better, right? 60% of the cost is eliminated, and yay, we win. Yeah, but remember, that 60% cost estimated. Even though we're looking at what's called an actual plan, I wish they would change the names. It's an estimated plan, and that is still an estimated cost. That 60% right here is not real. Further, you'll notice we actually only returned 16 rows instead of 265. And so if we look over here, we can see the number of executions is 16. So that means, or sorry, the number of rows was 16. The number of executions was, I always lose track of this. Why do I always lose track of this? There it is, gosh. Because it says number of executions, and I'm always looking for it in E. Number of executions is 16. So it executed 16 times, retrieving 1 row each for a total of 16 rows. Cool. It's a very, very lightweight operation. And it's only 16 rows, not 265. It's off by a whole 0. That means that estimated cost in this instance with this data set, and yes, that means I'm cheating, but in this instance, with this data set, that estimated cost is a lie. That's not accurate representation of the actual data. The actual data only returns 16 rows, which means this is not 60% of the cost. It's an order of magnitude off, a whole 0 off. Therefore, probably this bugger right over here is our issue. The fact that we've got a scan on that clustered index probably is, in fact, where we need to go if we were trying to tune this query. That's not to say we couldn't also fix the key lookup, because every single win is a win. But it does mean that you're modifying the index, and you're going to have to think about whether or not that affects inserts, updates, and deletes, and all this other fun stuff. So every single decision we make has got impacts around the edges. But that's not the important point for today. The important point for today is that now you've got an understanding of how to start to read execution plans, how to get going. It's not so much that there's one true path through these, but now you can see, you know that there's the select operator, and we're going to start there to get the details about the query. We're then going to follow the instantiation path, 0, 1, 2, 3, 4, right? And you can see it right down here. So 5, 6, 7, or did I count wrong? 8, 9. Where's 6? Huh. Not sure. Let's do this. Find node. Let's look up node ID. Where did 6 go? Huh, there is no node ID 6. It skipped it. Interesting. I never noticed that before doing this demo. That's, Not sure why. I'll have to look that up and figure it out. Anyway, you get the general idea, though, even if it does skip an ID, the actual logical construct is still the same. It starts to retrieve data from here. It goes into the nested loops join, which does, for each row in the top row, go to the bottom row to retrieve data, so it does a seek down here. Those return rows, so it goes to here, retrieves the data down here, returns rows. And it does this in a normal operation, 1 row at a time. That's why they are called iterators. Now, there are what are called blocking operators. And a blocking operator is easy to understand. A blocking operator has to do more, and therefore it's going to stop things until it gets all the rows. let's look at a blocking operator. This is a hash match join. A hash match uses each row from the top to build a hash table. And then it uses rows from the bottom to probe the hash table to find matching rows. Cool. So what it's doing is it's collecting all of the rows from on top. So it's taking everything has to get into here first. It then creates a hash table, which means it's stopping all the other operations downstream. Nobody else is getting rows until this hash match is complete, because it has to build the entire hash table. You can't start matching stuff without having everything, because it doesn't know what it would miss then. So it builds the hash table completely. After it builds the hash table, it then probes against the index scan, matching up the rows between the two. And hash matches are very efficient, by the way, in terms of they cover our sins. Usually a hash match is because there wasn't a good index in place, or you're moving so much data there's not, you can't use more efficient indexes, or the data is not ordered so it can't use a merge. So it has to go into this hash match thing. The hash match is there to cover up all of our mistakes, and it does a great job at it. So I love hash match joins. It's just frequently when I see hash match joins, I'm thinking like, okay, well, what else could I do to get around this? What kind of changes can I make to the structure? What kind of changes can I make to the code? It's not that it's bad. It's not bad, but it's an indication that maybe there's tuning opportunities. Maybe not. It really does depend on what kind of query we're running. But here, because we're doing a scan, because we're doing a hash match, we could probably look at trying to see if there's ways that we could put a probe in here and get, and figure out a good index to add. It's got another hash match. Again, that one's going to stop all output until it gets everything. Of course, the fact that what's immediately in front of us a hash match means that it's just going to sit here and wait for this hash match to complete its operations. As soon as it completes operations, this thing's ready to go, and then it starts going. So it's all pretty straightforward. There's nothing to that. But that's what a blocking operator looks like. And you can figure out pretty quickly which operators are blocking and which are not. Obviously, something like a nested loop, which is just going, hey, man, I got a row. Match it until it doesn't match, then move on to the next. Well, that's not going to block because it's just able to continually process. Index seek, what's it doing? It goes and finds the data, returns it. Well, it's not, it's a data retrieval thing. It's not going to block. But the hash match has to be a blocking operator. Cool. That's two queries. One query, two execution plans. How are we doing on time? We've got a lot of stuff. Man, we may have to go to 3 days of execution plans. We'll see how it goes next week. We're about an hour and 10 minutes in. I'm going to stop here because the next stuff that we start to introduce is rather time consuming. So I'm going to run this next week. We'll start from right up here. Matter of fact, I'll just put in, let's see, where's the bookmark? Hang on. I always forget. There we go. Bookmarks. Toggle bookmark. Cool. Save the file. We'll get right back to that next week. Okay. Based on all the stuff we've covered today, does anyone have any outstanding questions? Now, I will have to wait a second because there's about a 30-second delay between what I've just said and what you hear. So I'm just going to wait here until you guys get a chance to type in. Now, today was all very, very introductory. We're going to keep going on how to read through execution plans, how to follow the node IDs, how to identify operators that we don't understand, how to figure out what those operators are doing, not simply what they tell you they're doing, because sometimes the statements aren't entirely clear. But we're going to walk through a lot of different operators. Our first plan was very simplistic. This was not what is considered to be a complex execution plan. But even as a simple execution plan, you have to agree, there's a lot of fun information going on because we can look at stuff like the fact that the query timed out. Not the query. The optimizer timed out. Query ran fine. The optimizer timed out. The fact that this key lookup estimate was wildly off. We've got blocking operators. You've got a good overview on getting started with execution plans. So I'm seeing yes, thank you, thank you. Okay, cool. Well, thank you guys. And next week we'll be at the same time, 2 to 3-ish. We might run over to 3.5 hours on tomorrow. There's a lot of stuff or next week. There's a lot of stuff to cover on execution plans. It is a deep topic, and we're skipping some things. We're not going into how statistics work and how the optimizer works. We're mainly focused on just the results, how to read them, what to do about them, how to deal with them. So because I'm focusing this entire series of videos on tools. So not internals necessarily, but on the tools that expose those internals. With that, I'm going to go ahead and shut us down for today. I'm going to say thank you for attending, and we're going to keep going, and we'll get into a lot more stuff. So appreciate your time. Have a good day. And if you're watching this on the recordings later, don't forget about the Discord server down below that you guys can go to get questions answered after today. All right. Thanks a lot. Have a great day.